Imagine you're making a playlist of songs. You want to add, remove, or rearrange tracks whenever you like. How do we store that efficiently? That's where linked lists come in. Hi, welcome back to the very first video of my new linked list series. Today we'll understand what a linked list is and why it's so powerful. Now, what is a linked list? A linked list is a collection of nodes where each node contains data value, right? Contains data value and a pointer or reference to the next node. Now, how are arrays different from linked list? Imagine it this way. Arrays are like fixed compartments in a train, right? Arrays are like fixed compartments in a train. If the compartments are full, you just cannot add more. Okay. Suppose we have an array of elements 1, 2, 3, 4. Okay. And we want to remove this element. We cannot. Array does not provide us this feature to do it. Also, suppose we want to rearrange it. Yeah, we can definitely uh, rearrange the values. We can change the values, but the memory locations, the nodes, we cannot do. We cannot change, we cannot add. Once we have assigned an array with a specific size, in this case 4, and we want to add another element, say 5, we cannot do it. Array does not provide us with this flexibility. Okay. Similarly, we cannot remove any element from the array. We cannot rearrange the memory locations in the array. They are fixed. When it comes to linked lists, it's like attaching train coaches one by one wherever space is available. It's like attaching train coaches one by one wherever space is available. Now let us answer this question: why linked lists? Okay, so the pros of linked lists are: number one, dynamic size. Yeah, unlike arrays, we need not predefine any size. We can add nodes, right? We can add nodes as and when required. Okay. The second pros will be it is very easy for insertion and deletion operations. We can easily insert nodes in between two nodes, and it is very easy to delete any node from any point in that whole linked list. Okay, so what are the cons of using a linked list? One point would be extra memory for pointers. Yes, extra memory for pointers. So, as we know, in a linked list, we store two things. One is the value, and another one is the pointer or reference to the next node, which stores the address of the next node. So, there is extra memory requirement for these pointers. Okay. Another cons would be sequential access. Another cons is sequential access, which means it cannot directly jump to any index like array. Suppose we have an array 1, 2, 3, 4, and we know the indices as 0, 1, 2, 3. If we want to access this element, what we have to do is we have to simply do a of 2, which will return us 3. But this is not the case of linked lists. In linked lists, we have to iterate over each node, right, to find the required node. Okay, so suppose this is a linked list we have. Okay, and we want to find the value of this. We want to find the value of this node, the fourth node from beginning. Okay, what we can do, we just cannot, if this is a linked list, we just cannot do L at 4 or L at 3 to give me this value D. No, for this case, we are at here. Okay, so what we need to do is we start from here and we iterate to the next, right? And then from here we go to the next using the memory pointers, and finally when we come here we return this value, right? Okay, now let us look at the type of linked lists. So one, we have singly linked lists, which is basically one way. This is the very example I showed you in the very beginning. So there is only one pointer which points to the next element. There is only one pointer which points to the next element. Okay, and once we are here, suppose we are here, there is no way we can access this. There is no way we can access the previous one, but yes, we can always access the next one. Okay, because the pointer stores address of the next node. Next we have doubly linked lists. Doubly linked lists are back and forth navigation. Now how does a doubly linked list look like? So this will have two pointers, one pointing to the next and one pointing to the previous. Okay, so each node will have a value and two pointers. One points to the next node memory address and one points to the previous node's memory address. And the last one is circular linked lists. In circular linked lists, the last node points to the first node. The last node points to the first node, useful in round robin scheduling like CPU tasks or multiplayer game turns. Okay, this is helpful in CPU tasks, multiplayer games. Let's look into some bonus linked list facts and interview nuggets. Memory storage. Unlike arrays, linked lists are not stored in contiguous memory locations. Each node can be scattered anywhere in RAM and the pointer keeps track of the next node address. Right. Cache performance. Arrays are cache friendly because elements are side by side, but linked lists are not cache friendly since nodes may be scattered in the memory. This sometimes makes arrays faster in practice despite higher insertion cost. Variation of linked lists. As we have already seen, linked lists are of three types: singly linked lists, one pointer forward only; doubly linked lists, two pointers forward plus backward; circular linked lists, last node points back to the first. This is great for round robin tasks like CPU scheduling. Space overhead. Every node stores data plus at least one pointer, so an overhead space is required for linked lists. This overhead makes linked lists heavier than arrays, especially as memory is limited, right? Real life use cases, as we've already seen, redo undo in editors, this use a doubly linked list. Browser history navigation, this as well uses a doubly linked list. Music video playlist uses circular linked lists where your first song gets played after your last song in that list, right? OS task scheduling, in this also the circular linked list is used. If you found this video helpful, please like, share and subscribe to support the channel. It really motivates me to keep making more videos. In the next video, I'll do an in-depth explanation of linked list insertion and deletion operations along with the code. See you in the next one.